and Espressif code together. And I think this was a really important task I did because one of the main things you guys are going to have to do during the beta design is write a lot of it in Espressif, because Espressif code is more stable than Arduino. But if you have both Arduino and Espressif code together, you can use both of the stable Arduino code and the Espressif code. It also makes migration so much easier because you can change line by line or file by file. Because if you try to migrate the entire thing to Espressif without testing it along the way, you're going to run into a lot of problems, and it's going to be a big headache, and you won't know what went wrong and where it went wrong. The next thing I did was I verified the RTOS and the nozzle modifications. This was pretty standard. I just kept rescrewing it, measuring how much time in like a minute the nozzle would spray, and I just modified the code so that the spray rate was the same as the nozzles. I also tested the RTOS tasks and like monitored the machine to ensure that everything works. I also soldered and debugged hardware. So some of the alpha PCBs, I just put connectors on it, and one of the sensors or heaters wasn't working one time. So I diagnosed that issue and then unsoldered it and resoldered a new one, and that also worked. Over here you can see this is the AC-DC unit issue. So what happened is that none of the DC components would get any power at all, right? So I just tried to figure out the issue, but I'm kind of sad that I didn't, because all I had to do was just unplug and replug everything, so it's probably a loose connector. But you can see the importance of like documenting these tasks and debugging hardware and being able to put a multimeter on it and know the exact location of where the bug is so you can assess it. Niagara College, I also participated in the NC study. So what we did is we went every week to Niagara College because they have a greenhouse and they have green industry facilities, and we reloaded a new batch of food and re-uploaded code that was working. And sometimes code malfunctioned or components didn't work on the spot. Like one of the times the heater wasn't working, so we had to fix that. And sometimes we brought back units to be fixed, like the AC-DC unit wasn't working, and unit 3, which was the previous slide that I was showing you. The next thing I did was I hosted a local web server. So the ESP32 can create a website, and if you're on the same Wi-Fi network as the ESP32, you can look at that website by going to an IP address or going to a local host, like a website that's only available on that Wi-Fi network, which is what I said here. It's only available on the same Wi-Fi network. So if I'm home and the machine is here, I wouldn't be able to access it. Which brings me to the next thing I did. I created a Firebase web application. So what this does is the website can now be accessed from anywhere in the world. So let me just skip along in the video. So this is kind of how it looks. You have a component test unit at the top. You have a checklist just for their visuals. You have a table for You have a table for the components, and you can turn each one on and off. Sorry. You could turn each one on and off. And the great thing about this is I created a Figma to kind of help the future co-op student understand. The way it works is it communicates to a central database, okay? The web server can send data every time like a button is pressed, and the ESP32 is listening to the incoming data like every 3 seconds or so, and it's updating. Okay, and then when that value changes, it changes the global variables and like the different functions that happen. But the ESP32 can also send data. So let's say I go here and I enter the command C31. It gets registered in the database, and the web server is always listening to those changes. So if a 1 becomes a 0 and a 0 becomes a 1, which I explained in this video, it changes the color of a button and like other HTML properties. And I added a link here where you can visit the website, and it's also like features authentication. So if you put the password, if you put the username default at gmail.com or testing at gmail.com, and then 1 2 3 4 5 6 7 8 9 0 is the password, you can log in. If not, you can't, and you wouldn't be able to control our units. Next, I added unit test logics, which is C40. So if you if you connect to the ESP32 and type the command C40 for 10 seconds, it turns off each component on and off. So it'll turn the crush motor on for 10 seconds and then turn it off. And then do it in the reverse direction, the same thing. And then it goes through those list of components from the drying motor to the drying heater to the drying air pump to the water pump. And that way you can check if everything is connected without having to manually go through each thing and remember along the way. Which is why I also added that checklist on the website, so you can check it along as you go. The next thing I did was I tried setting up a hardware debugger, and what a debugger basically does is it can let us put a breakpoint at a line in the code and just pause the code there, right? And then see how everything is working, what the variables are equal to, what functions are running, and you can go line by line through the code. And I tried setting up a hardware debugger for this. In the beginning, it was working, but because the code base started getting too large, I don't think the debugger was able to handle it. So it stopped working. So I thought, okay, it might be a driver issue. So I went on Platform.io, I asked online, but they didn't really help. So the next thing I tried to do was I tried setting up an emulator. What an emulator is it's software on your PC that you can just run, and instead of having to connect to a machine, you could just do it right on your PC. And again, this would let us pause code, it would tell us why stuff crashes, it would give us so many debugging functionalities. But that didn't work on my PC because there was a Docker issue, and I tried searching it up, but there wasn't enough documentation because I could get into the specifics, but it's highlighted on my Notion page. And then I tried doing it on the PCs over here, and the computers over here didn't work because they had to have a virtualization setting enabled, and I couldn't find that in the settings. So I tried going into the BIOS, but there was nothing in the BIOS. So I just decided to ditch that for later. And when I was working on the website, I found a huge bug and I couldn't figure it out, and I was spending 2 days on this, and I was trying to manually go through the code and add print statements, and it wasn't working until I found this tool over here. And basically what this tool does is you can basically, you give it your the file that builds after you run your code, called an elf file, and you paste it over here, okay? And this is basically the memory address of every function and a summary of what happened. So it tells you the exact line number that caused the crash and what functions called that line number. So it's very easy to know, okay, I can just comment this out, or the issue is here, so I don't need to waste my time looking for it. The next thing I did was I implemented OTA. So what OTA does is it allows you to upload code to a machine without having to be connected to it. So you can do this over Wi-Fi, and you could do it anywhere, which is really great because let's say you put a bunch of units in coffee shops or in someone's home, and then you realize later that there's a bug or there might be a security issue. What you do is you just upload a new file to Google Drive, right? And then you come on this website and click on the Update OTA. It will grab that Google Drive folder, that code, and then update the system with that new code. So that way, any buyers of the product don't really have to do anything. All they would have to do is just click a button on their phone, and then they update the system code. I go through this in detail a bit more over here. You can see that this is it was a Google Drive folder where I was uploading code to, and then I did some other things, I went to a hardware tech pitch and the job fair, and I networked with people, talked to them, got their experience, and expanded our network basically. And in one of these events, the people that actually won the hardware tech pitch, they were using Espressif ESP in their system as well. So it's a nice connection to have people who know the same technologies, and it prevents you from wasting your time on learning things and messing up along the way. I also did some other miscellaneous tasks from 3D printing, laser cutting, took a trip to Inertia, I brainstormed in some meetings and discussions, but these are all things I did on the side. I also built a mobile application, a phone app. So this is kind of how it looks, and I have the code on the side. There's 3 pages, a home page, a food waste AI page, and a profile page. And in the food waste AI page, like I show here, you can pick a picture and then submit. It isn't really, the AI model is not on there yet, but it's just a demo of how it's supposed to work. It's also connected to Firebase. And the ESP32 is also connected to Firebase. So the app and the machine can communicate. It also includes authentication, so you can sign up, you can log in, and if you forget your password, you can click on Forgot Password, and then it sends you an email verification link where you can reset your password. And here I show how like users can assess their compost quality. So if I pick, right now I'm just picking a picture of like food waste. I click on submit, and it takes about 3 seconds to analyze. And then it shows you, okay, 60% of it's raw chicken meat, 30% of it's cabbage roots, 10% of it is fish bone, and it highlights the different parts of the image, and then it tells you the compost quality is 83%.
Good game.
The next thing I did was I tried messing around with like AI data labeling. So the purpose of this task was, in the next generation of the machine, we want users, when they put their food inside, it's gonna label their food and tell them, like in the previous slide I was showing you, 60% chicken meat, 30% fish bone, 10% cabbage roots. It's gonna do that exact thing, but that was just like a dummy demo. The purpose of the AI is to actually assess the food and have it do it through the machine eventually, instead of just through the app. But to do this, you have to feed the AI a bunch of instances. So you have to show it, okay, these are like 1,000 pictures of a banana. Now when you see a banana, you know that it's a banana in the picture. But the problem is, this involves a bunch of manual labeling, and I kind of used an example of animals, humans, and like trees. So like you'd have to individually trace and then say, oh, this is a dog. And that was taking a pretty long time. So like I tried experimenting with different ways we can make this process faster. And on my Notion page, I list a bunch. I list like 6 different data sets that we could try. We haven't tried them yet, but they're really good. One of them is like 6 gigabytes big, and it has like so many like food items. A lot of them are dinners, but they might be able to work for food waste. The other thing was I tried looking up models and seeing, okay, how easy would it be to create the model myself and then iterate through the data sets instead of having Ryerson University do it. I look up tools like RoboFlow, Zero Shot, which basically, Zero Shot's a tool where it's literally state of the art and it's kind of new, but let's say it never saw a cat before and you give it a cat, it just learns it's a cat. It doesn't need any examples to do so. But it was kind of like university PhD level, and it was not really in the process yet. So what I decided to do is what I'm doing here. Create an image segmentation model. So what this does is it automatically finds each instance for you, and it downloads the instances separately as images. Okay, so that way you don't have to trace around. And if I skip ahead, you can see that I just go over the code a bit. It downloaded each instance as its own picture. So like the human is one, the dog is one, the horse is one. So you can go on any picture. You could just trace out the entire thing, right? With the auto segment feature, which I should be showing. Yeah. So you just go over the whole picture. Doesn't really take much effort, and it just segments it for you. And that way, in the future, if this tool is improved, it could be used with the food. Next thing I did near the end of my co-op is worked on the beta test jig. So what the beta test jig is just a bunch of sensors strapped onto a controller, and we put those sensors in the beta design, and then we can monitor oxygen levels, temperature levels, moisture, and like the weight of the food as it goes along. So this started out as a breadboard, and I had to verify the pinouts first. So I had to see, okay, does the sensor work on like pin 3? Oh no, it doesn't. Okay, now I change it, and go through that process of it. And over here I kind of show the spaghetti code, which is right now, the spaghetti wiring, which right now is on my desk. It's connected to the ESP32, and then all the code and stuff is here. So like it tells you, okay, the oxygen level. Yeah, so here I'm just calibrating the load cells. You put like a weight on each load cell and tell it how much weight is on it. So that way it knows, okay, if you put something heavier, all right, now I know it's 2 kilograms. And in the rest of this video, other than explaining stuff, I go through the schematic and the PCB that I made that has yet to be manufactured. So this is how it looks. And in 3D, once it's manufactured, it should look something like that. And shows you the outline of where everything goes. Now, what are the next steps? So my co-op term ended, but the purpose of this presentation was to motivate a future co-op student and show them what they can do to continue like walking along the journey. The first thing I would do, let's say like you're at 0, I'd finish the ESP IDF course, which was really helpful and it gave me ideas such as OTA and debugging. Then I would finish the function mind map, because then you kind of get a feel of where everything goes, and it's on the it's in this PowerPoint slide and on one of my Notion cards. Then I'd find a bug that doesn't really work, and I'd go through it and work on it yourself. So one of a really minor bug is that on the machine, when we run C34, which is supposed to switch the direction of the compost motor, what we have to do is we have to type in C33, which turns the compost motor off, and then we type in C34, and then we type in C33 again, okay, to turn it back on, and it switches direction when it's turned back on. But what the co-op student, what they could start by doing is find a way to just type C34 and it just switches direction without us having to turn it off, okay? And it's not a big deal if you miss something up because it's a very minor bug, but it lets you learn along the way and know where everything is. And the other thing I realized I could have done better during this co-op term was I could have prioritized critical tasks. It was honestly really fun for me to work on like image segmentation and just not know how to do it, and that's okay, because Hawaii told me about ChatGPT, which basically just did my job for me, and then I asked like the AI, okay, how do I do this, and he gives me a bunch of code, and I learned so much along the way because it explains the steps for me. But one thing I should have done was I should have prioritized like critical tasks, even though they weren't given to me. So for example, for the beta design, I wasn't really involved in it, but I could have been more involved. I brainstormed just a little bit, but I could have maybe created like a SolidWorks file and like a simulation told why, okay, if we add this to the beta, then it makes our crushing job a bit easier. And that way, my impact on the company increases. Now I leave the stage up to you. It's because it's time for your ideas, inspiration, and creativity. Thank you.
Excellent, very good. I can't clap because I'm holding the phone, so verbal claps.
Thank you.
Okay, let's do some QA maybe.
Sure.
Yeah, I would say is you cover so much work you have done and tasks and subjects, and very impressive. Thank you very much. And I've done how many? Probably 5, 6, 7 co-op students as a supervisor.
Okay.
You are the best. You absolutely.
Thank you.
You the impression you get to be you get on this, you make a result. That's not easy. Okay.
Thank you.
Particularly for the co-op students, they get on may not necessarily have the results. Okay. that's a very good thing.
Thank you.
Question.
Mm-hmm.
Since you cover a lot of things,
Mm-hmm.
right? And one of the things, and also the transition
Mm-hmm.
to the either to our company teams
Mm-hmm.
or to the next co-op students. How that, I know you're
Mm-hmm.
walking through how that documentation done,
Mm-hmm.
facilitated in that transition.
Mhm.
Somebody can continue working some, the matters you work on that, and they're able to catch up and continues.
Yeah.
How about that?
Good question. So, if this presentation is not enough on Notion, if I go to my to-do,
To-do list, right?
Yeah.
In the Notion, yeah.
so everything I did with, and it's like in progress, if it's completed, if it's blocked, it's all here. And if I go to, for example, the website, over here I just include like the background of what it is, a video demo, and I also included like the Figma flowchart that they can visit themselves. And what I didn't include in the presentation was like the code explanation. So this is like an 18-minute video of me walking like through the code and telling them, okay, this is how it works on the ESP32 side, this is how it works on the web server side. And I also included like resources and additional links if they're still confused how I've like figured it out along the way. And some of these resources are like next steps. So like under next steps, I wrote, okay, these are the things you can do, and I listed them in order of priority. And then I told them, okay, if you don't know how to do these next steps, resources like video 1, 2, 3, 4, 5, 6, and resources can help you do that. And all they have to do is just visit the videos and try to implement a bit of the code and test it out for themselves.
Mm-hmm. Good, very good. They will know the location and documentation is. The next go ahead.
Did you fill out that Voyage?
No, I
thing?
have to do that.
Okay.
Okay. The next question is from all those, based on the task or the
Mhm.
not just a task, right? Because somehow the matters or the things you have to work on,
Mhm.
and how far to, I'm talking from the start,
Okay.
to the finish, the completion,
Mhm.
how far you wanted to, close to that completion point,
Mhm.
and how much work still need to be done by the next or whoever
Okay.
to carry on that. What is status like this?
That's what the Voyage chart was
Oh, is that-
designed to
Oh,
answer.
that's then to the explain it.
I have
So
a
he needs to
picture.
fill out that to answer that question.
Hawaii kind of did a bit of it for me, but like everything I did, it's like
Voyage,
done in
okay.
progress. Most of the things were like 80% done. So for example, the app is like 80% done. There are just small tweaks like fix the arrow needs to be at the top left.
Mhm.
The profile page, add the share button, and it just needs to be put on the App Store. And there are like videos on YouTube and tutorials for that.
Okay.
And I put that in the next steps section. Some things like, let's see, what's the least thing that's done? Like, okay, I think the thing that like would require the most work is like the AI image segmentation.
Okay.
Because if we try it with our images, instead of like creating individual instances, it groups foods together, right? But the thing is that like when I'm working on a task, as I'm working on it, I'm like, okay, how much work am I putting into it? How much time am I putting into it? And is it really gonna give us the result we need? So let's say I'm like only done like 50% of it, and I'm like, wow, 50% of it took a really long time. Do I really want to spend more time? And I kind of see what the rest of the company is doing. So for example, you guys have Miles, and I think other students that are also working on the AI image segmentation. So if I devote my efforts to this and it doesn't end up getting used, then what's the point of completing it? So,
Right.
which is why I talked about in my presentation about like prioritizing critical tasks. So look at what the company's most important to the company and then focus on that.
Right. Okay. The next question is, you through your presentation, that's the first time I knew you grasped a good number of tools. Okay. How that availability for us is just for yourself on your computer and nobody else
Yeah.
has access, or we have a good access to the tools you use as well.
Good question. So they're on my Notion page. You can also I included them in each Notion card. So like when I talked about porting code to like Platform.io and ESP-IDF, I made a Google Docs about setting up that environment yourself, and I put the steps. So first you download VS Code, you add Platform.io as an extension, and then if option 1 doesn't work, there's also option 2, where you can run ESP-IDF here. And I added like images and like circles of where to click and stuff. And same thing for like the stack trace debugger. It's over some stack trace. Here, let me just Control F. Stack trace debugger. I other than the video demo, there's like if you go on GitHub, I linked all of this. It just basically tells you how to install it, and how to set it up and how it should work.
Okay. Yeah, are those you tried is a free version?
Yeah, all of them are free.
And yeah, use the free version or always questionable. Okay. How about that idea where there is a chance for this free version, the tools we use, there is a business or commercial revision, I think.
Like if you use it for like your own commercial purposes,
Yeah.
or if somebody else starts using it for their commercial purposes and you can't use it anymore. Which do you mean?
I'm saying
Like
can use for the commercial purpose. It was just for the free version.
yeah, you can. The thing is, like some of these tools, they're just helping you figure out the code. They're not actually in the code,
I see.
right? So you could just use it yourself and like, nobody knows.
Oh, I see.
Plus, it's open source code,
Okay.
and they don't really have like a license to protect themselves.
Okay.
They just do it so that other developers can like benefit from it.
Okay, those something I'm not that area, expert. We have to talk to internal team, see how to, to address this, because use the open source, we have to be always careful. I'm not for your work along the way. Okay.
But that's just the tool. It's not really like the code itself.
Yeah, I got it.
Most.
Yeah, we have the scan of all the libraries. It's actually in the code.
Yeah.
That was completed for Mark's code base.
Yeah.
It's a good idea to do it for Matthew's code base
Okay.
Yeah.
to see what the differential libraries are used now.
Mm.
It's not much because we didn't increase many new features besides the OTA and the web server stuff.
Yeah.
But it's a good routine thing to look at.
Mm.
Yeah.
Add it on the. Yeah. We could ask the next co-op student to do that.
Okay.
Get started.
Okay. The next sentence,
Mm.
which is critical in the rules for the company. Any secrets, church secrets, you touch it, the information, you have to, after you finish your job, you have to return the company.
Mm.
Okay, any notes, any logbook,
Yeah.
anything, you have to return to Hawaii. That's a rules. That's is a protection for the company.
Okay.
Okay. All right. Thank you very much. Well done, and I really appreciate it.
Thank you.
Thank
Sure, my thumb is in the picture.
you. Should I add it?
Oh yeah, that's good. Yeah.
Oh yeah, that's a good idea.
Yeah.
Yeah. Thank you very much.
Yeah, very successful co-op term.
Yeah.
Yeah, I like how you said. Again, the analogy is stay on the critical path, right? It's hard to do it as a co-op student because people don't naturally trust you.
Mm.
What if you fuck up? And then that's what, according to George, like anybody with co-op student, the expectation is not very high,
Yeah.
honestly, right? So to give you any critical path task is a big risk, basically. So there's that trust building exercise. Say, hey, I can actually deliver.
Yeah.
But unfortunately, it's only 4 months. So after we know that you can deliver, you're already gone. So
By the way, you're welcome back.
Thank you.
Up to you.
Yes. I mean, I think Matthew can get to places for sure. But that's the struggle for co-op, right? How can you actually get the work before you're able to deliver the work for co-op is hard thing,
Yeah.
right? Building that trust, of course, the resume, the stuff you worked on in the past is gonna help you convince people, hey, give me more important, more impactful work, right? But at the same time, stay alert, right? Spot. It's like there's some high valuable meat out there, and you're the vulture. You gotta have the good sniffing skill to see, okay, this is good work. I gotta, even though it's not assigned to me, but obviously these guys are too busy to.
Yeah.
And if I jump on it, I can speed things up. You just jump on it, see, knowing that people would appreciate it
Yeah.
because it's a critical path, right? You gotta develop that sense of, smell, and that involves understanding what the whole company is doing, what are the struggles for everybody at every level of the company, so that you know what people are doing, who has the ball, right? Who has the ball? Gotta keep your eye on the ball. Yeah, that's usually not expected of co-op students. Most of the time is they're very agnostic who has the ball, what a ball is in the first place, right? So I think now you have a good idea of where the ball might be, but you gotta keep track of where the ball is and who has it, and grab it if you think it's yours for a certain period of time, right? Yeah. But yeah, I think your work definitely is very good. Mostly it's on the R&D side, okay, because we're currently in the R&D phase for this term. But going to the next term, that's when the juicy stuff, more meaningful work, will so it's like timing thing, right? More product development activities. We deal with supply chain, so the sensors, we deal with the components. Everything would be more industrial level instead of R&D level. Like all of the sensor you did for the test rig, for example, is much inferior compared to these more like good sensors and stuff. So naturally, when you work with them, the value is lower. You see? Yeah. Because the subject matter is not as sophisticated. Yeah. Right. But that's the timing thing. It's out of your control. So it's like a luck thing. Not as lucky, but yeah. But that's the nature of work, right? Yeah.
I mean, the point is just to like learn and develop your skills. So I think in either area, I would have learned and developed. So like I'm happy with how it went.
Good. Yeah. I think your written communication definitely better. Could you click through the tasks that is in progress?
That is like
Git repo. Okay.
I think this is like the Notion card that I put the most effort into it. Because while I was doing it, I was like, oh, there are more ideas. Like I was talking in the presentation about like a 6 GB worth of, like this one. This one's like 6 GB worth of food images. Might be like a good use of time just looking into that.
Gallup Labs.
This one, like the less time I spent on it, the less time I really spent on the Notion card.
Okay, let's look at the next up, the stuff in the backlog.
Oh, if I didn't really work on it, I didn't.
Okay, that's fine. So please write something here as well for the co-op, next co-op to read, right? Okay. For example, you did do some inventory management stuff, right? Point them to, maybe there's Excel, maybe there's no Excel. Point them somewhere. Say, hey, what are the things you should do next up for inventory management, for example, right? Same thing for OKRs. I know again, OKRs not really applied to co-op students, but if you were to do OKRs, and what's acrylic laser cutter, like you did stuff for all of these tasks already. It's good to just briefly talk about them, give pointers. Okay. Again, the audience is the next co-op student.
Okay, have something under each part.
Very good. Git repo, where is that logged? I know it's on your Matthew@virgohome.io email.
I think I put it somewhere.
I think you have multiple repo, right?
There's two. One for like ESPDF Platform IO and the phone app is all under the same thing, and then the other one's just the beta test jig.
Gotcha.
I can. It's probably under one of these cards, but I forget which one it is. I'll just put it under like a GitHub repo.
Yeah.
Or
Yeah.
put
Call
under
it.
here.
Yeah. Put it here. GitHub repos. Yeah. And so a good practice for these repo is to write a README file. So since you already did the documentation, inside Notion, right? It's good to again, just put a link in the README file. Be like, hey, click on this link to get in-depth knowledge of what happens to this repo.
Okay.
Right. Right now the repo is sort of hanging. You can only go from Notion to the repo, but if people go from the repo back to the Notion, you want people to not get lost, basically. You see?
Gotcha.
That makes sense, right?
Yeah.
Yeah, but all of this is like written communication thing. It's all about how to make it easier for people to understand the stuff you did and be able to find stuff when they need. Good. And that's it.
Very good.
Oh, for the next term, I think I asked you to think about it. Would you be willing to do part-time? Potentially work on some tasks on the side?
I thought about it, and if I commit to part-time, then I'm gonna have to commit like a bit of time. Like, I don't mind helping Joseph, like if Joseph is stuck, do you know where to go from here and here? Like, I don't mind giving him pointers and like helping him set up something.
Yeah.
I just, if like I work part-time and it's like monetized, then I'm gonna have to like force myself to make a commitment, and then I'm gonna have to take away from like either like my schooling or like my personal projects.
That's right. Yeah. And that's the ask.
Yeah.
Is to take away from, let's say, your personal projects. Again, the argument here is next term we focus on product development. So that, again, that's where the juicy stuff comes in, right? If you say I help with a product instead of I help do R&D, that's completely different on your resume. It's just a very good opportunity for you. And Joseph came in a very good time. That's the time. But I feel bad. I feel bad for that.
No,
but this is a good
not
opportunity.
Bad. R&D is very critical.
Yeah.
I think you have a knack for R&D. You're probably passionate about
I
it.
always value to R&D.
Right. But again, my point, from the entrepreneurial business side, right? Like, to be a real engineer, you gotta work on actual products.
Yeah.
Not just.
Yeah, I know that for engineer, you see the product commercialized, put some home or the stores.
Yeah.
That's my point. It's different thing, right?
It's very different. Very so yeah.
Your achievement, right? I know.
Very different.
I guess the question is, what would I be working on?
Something on the critical path, potentially, relating to product development.
Okay.
So we're looking for embedded engineer. Like right now, we couldn't find anyone that's very good. Yeah, but think about it.
Like, I guess the question is like, what would the time commitment be? SD for is full.
That's something to be negotiated, right? We don't want you to promise something you cannot deliver, right? Also, like it's a balance. We don't want you to flunk in school either, right? So I guess it's really a question for you, how you want to manage the part-time. Again, it's part-time. So like maximum 20 hours per week, maximum, I would say. Maybe 10 hours, even sometimes 5 hours, right? But yeah, that basically the more hours you can commit, the more impact of a task we could give it to you. That's the thing. I mean, for you, think about it. For you, it's just a time commitment. But for us, it's the product.
Yeah.
Like, if you fuck up, the product is fucked. It's more risk on us.
Yeah.
To be honest, but we want to involve you in some way or form. I think it's beneficial for you and beneficial for the company as well. So. Okay, I'm gonna ask you to think about it again. You can get back to me. Say, okay, I don't wanna take on these type of commitments. at this point because I have more important whatever. It's fine.
Yeah.
Or okay, I'm willing, and here's the time commitment I'm thinking per week. It's okay. Don't need to think about it right now. Just think about over the weekend or something. The holidays or something.
Okay, the one check. Did you feel usually the Waterloo University has assessment for each co-op student. Did you feel that assessment?
Not yet.
Yeah, okay. That I think is critical for him.
Yeah, we did the preliminary marking already between the two of us.
Good, good.
The only thing that's a bit on the low side is the written communication. So I wanted to see this today before I give him the level 3.
Yeah.
I think he deserves a level 4 now. Good job. So I can bump it up with evidence.
Yeah. Good. Okay, there are a lot of things is I saw Matthew has done from the AI point of view, lots of segmentation and labeling, right?
Mhm.
And then if I recall, reference the project proposal, and when we get into the segmentation, I think it should have a lot of collaboration between our team and their team.
Mm-hmm.
How those communication go through that.
Emails.
Dr. Richard get updated and get feedback when we work on
Constantly.
it. Constantly. Okay, good.
Yeah, started a month ago.
Okay.
And we already sent them the first batch of label data,
Yeah.
right?
The only thing I ask it is because the segmentation, the requirements is very, very, say, whatever, related to what they approach, their methodology
Mm-hmm.
down the road, the algorithm and the development related to. Yeah, we whatever we work on the approach and the way,
Mm-hmm.
and should be able to meet their requirements,
Yeah.
not waste the time. That's
Yeah.
why I'm asking.
Yeah, good.
Yeah.
But that's the top priority.
Good.
Everything we do is send them, does this meet your requirements
Yeah.
multiple times. Yeah, we already resolved a lot of issues that they brought up. It's probably documented in the data labeling notion.
Yeah.
Good.
I think they have 2 or 1 poster doctorand to work on that project. Yeah, and then to work on the algorithm. Yeah. They were. Okay, all right, that's all from me. Thank you very much again, and congratulations, and good luck
Thank you.
with your school. Yeah.
Awesome. I'm gonna hit the stop button now.
I will.